I think. Welcome to Q&A Friday. It's Q&A Friday. And my name's Thomas Dimitrovich, as you know, or you should. Maybe you do, maybe you don't. So I'm just in the process of looking at some of these questions, and there was a file that's missing. Anyway, welcome to Friday. Steve Froming in the house. How is Steve Froming doing these days? Hopefully you are doing well. And my phone, she is ringing. No? No. Okay, so couple things. It's Q&A Friday. So, Steve, I am going to talk first. I want to answer a couple questions here, but I was just looking. I'm realizing right now that some of my files that I put, hey, Paul Flager, hey, how you doing? Some of the files that I put up on some of my links that goes to Dropbox, apparently, after so long, expire. So fine and dandy. Excellent. So what I'm trying to do is figure out how to get that done, how to find these files. So the fault current calculation lab that I did, which has got a lot of views, very happy about that. I've received a lot of questions, very happy about that as well. So if you recall back, I'm not sure when I did it, but back, and I was just trying to figure out when I actually did this program. I can't find the date. But I don't know if it was last year or the year before, if it was during COVID, after COVID, I don't know. But in any case, it was Thursday Tech Talk there's the date. February 4th of 2021. So February 4th of 2021, I did a program on calculating fault currents, and we did it. It was a what do I call it? A short circuit calculations. It was like a working session where we went through the per unit analysis. So that was kind of cool. And I had a couple links in there. I had the single line diagram, and I had some of my handwritten papers. And apparently, I don't have them. I can't find them up on my Dropbox anymore. So I'm not sure where they went, if they were automatically deleted or what. But in any case, I am going to have to work on trying to find those links for some of you who are looking for it. So I looked in my Corona Tech folder. I called it Corona Tech. Jeez, oh man. It's not on my ISO file. It's not on my OBS backup. It's not on my Stream Deck. It's not even on the main page. So anyway, I will be working on that. And what I might do, here's what I might do. Mr. McCamish, good to see you. Thanks for the text today. So what I think I'm going to do is I'm going to reschedule and do another session, which goes through the per unit calculation of fault currents by hand, development of all of that jazz. And I'll do that again with maybe a little bit different one-line diagram. So I don't know, because I can't find those files. Anyway, so today's question. P, the first one, I get this email, and I'm going to read this to you guys and gals out there. Where is my email? The email says, here it is. All right, here's what it says. I have a question that was asked in one of my classes. Not my classes, this gentleman's class, which I'm not going to say his name. I don't know if he's out there. Yes, he is. You are out there, my friend. The class is 70E, and another cool thing is we got John McCamish out there. Good afternoon, Nihad. John might be able to chime in on this as well. I'll give you my perspective on answering this, and we'll see how this goes. So he says, I have a question that was asked in one of my classes. The class 7 is 70E, and the video is one where the arc blast blew the doors off of a disconnect into a mannequin, taking off his arm. it's on. Are mannequins a him or a he or a she? I don't know. I can share the video, but I believe I've already seen it, and you are correct. I have seen it. He says, here was the question. How can I ever feel safe opening or closing a disconnect if this may be the result? Now, he gives me his answer. This test was to test clothing and gear to see how it performs in an event. They had an available fault current well above the short circuit current rating for the sole purpose of the test. Properly installed equipment takes available fault current, blah, blah, blah. So I'm not going to get into his answer. So here's, and he says that the gentleman who asked, or the person who asked the question, was quote unquote freaked out. And I know what you're doing now. You're going bump, 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 bump. No, don't do that. It's not that type of freaked out. So I've had this similar question before, and I'll tell you how I answer it. An arc flash event is violent. There is no doubt about that fact, right? We have many videos, and I'm just going to take and see. I believe I have some videos of an arc flash event, and I'm going to see if, in fact, that's what I'm going to do. Arc flash. So I got to go. I have to go to my D drive. I go to NFPA. I go to 70E Edward for electrical safety. I go to presentation and I go to videos, and I'm sure I've got an arc flash event here. So, and we do these presentations, right? Here's one here. Here's one here. Hold on. Media player. Right, so let's do this. I go up. Okay, so that's one of them. That's one. Here's another one. Whoa. Wrong window. Johnny B. Good. Here's another one. Okay, so there's another one, right? And that's just bad PPE there. How about this one, right? How about this one? You've seen the arc vault. This. Look at that blast, right? Now there's no mannequins in here. There's nothing that's demonstrating the impact of an arc flash event on an individual. But do you want to be in that ball of flame, right? Nobody wants to be there. So what I typically will say is that we have to always remember that personal protective equipment is your last resort. When you get a person who says, this is freaking me out, right? And the answer to that is good. It should. It should freak you out. It should make you want to cross your T's and dot your I's, because you definitely do not want to be in that type of environment. Personal protective equipment is not going to protect you from flying debris. It's not going to protect you from any projectiles that come out that might pierce, right? If you get thrown against a wall, it's not going to prevent you from getting broken ribs, etc., etc. So personal protective equipment is when everything else went wrong. You don't plan for it. You have your policies and you have your procedures. You should be following. You should be following first the National Electrical Code to make sure you installed things correctly. So for those individuals, when they say that, I say when I show a video like this, right, and I show the force behind an event, and they say, well, what's PPE going to do for me there? My answer is, right, what's it going to do for you? It's going to prevent you from getting an incurable burn. It's not going to prevent you from being pushed away from the site. It's not going to prevent that projectile from hitting you possibly in the head or in the torso or in somewhere that's going to break a bone. It's not going to prevent you from being thrown off of maybe a piece of scaffolding that you might be on or any tall area. And, oh, by the way, if you're wearing a fall harness isn't going to prevent you from dying from the fall. Right? There's a misconception of security when you are wrapped in a 40 cal outfit or when you put that harness on. You know, I bow hunt, okay, and I get in a tree. I used to when I didn't travel as much and when I was younger. But I had a loggy bayou. I called it the death trap, and I would climb my tree, do my acrobats to get up there, and I had my harness. And I didn't have a harness that was just around the waist. I had a harness that went around my legs and whatnot. And you know what I used to think about is, okay, let's say that this tree stand falls. I'm in the middle of the woods, and the way I hunt, the way I do my, you know, I carry my bow and I walk through the woods. I don't have, my family would know generally where I was. They wouldn't know exactly where I was. So if I'm dangling from a tree in a harness, cutting off the blood circulation to my legs and all that jazz, that's not a good situation to be in, even if you have a harness. Yes, it's going to prevent the fall and the abrupt stop at the end, but we've got to understand the magnitude of what these protective devices are there for. And personal protective equipment is not what you lead with. You've got to make sure that we follow this book. That's why we teach the National Electrical Code. That's why we don't cut corners when it comes to the NEC requirements, the bare minimum requirements. That's why what I always tell you, go above and beyond. This is not a design guide. This is not something that we use to design every power distribution system, and that's all we do. We can go above and beyond. And then we follow everything that's in here. We have the pre-planning. We got to get our head in the game. We have established an electrically safe work condition, right? Lockout, tag out principles. Why do you want to make sure that you lock everything and tag everything out? Because you don't want to be in front of this. This is a reality. It's a reality. And it is a level of, what do you call that? There's a term for that. It is a sobering moment to understand the magnitude of what happens when we screw up. What do I teach about on my channel? I teach about reducing this, right? And we have solutions that makes this a thing of the past if you go above and beyond the bare minimum requirements of this. Okay? So I'm going to play this out. You saw the beginning portion of this. Okay? And this is what I tell people. I say, look, you don't have to live with this. You don't have to have, you have this whole, I'm going to play it from the beginning again. You have 85,000 amps of standard equipment. This equipment is not being misapplied. Remember that. This equipment is not being misapplied. This equipment is operating. It was installed per the code. It is perfectly fine. Do you want to be in front of that? Heck no. You want your electrical contractor, your NECA contractor, you want your design engineer, your professional engineers laying it out to make the decisions to use this equipment instead of that other equipment. So that's the event you're looking at. This is why we make these technologies, because of exactly what your email said. It left you, that individual was left standing there saying, wow, what good is my personal protective equipment when I'm faced with that type of event? And that's a valid concern. And again, the way I answer these questions, how can I ever feel safe opening or closing a disconnect if this may be the result? Establish an electrically safe work condition. Make sure that you install things correctly. Make sure that you review the application correctly so that doesn't happen. That's the only thing we can do. And remember, in the hierarchy of risk controls, personal protective equipment is your last resort. And this book, 70E, is changing, right? And I'll tell you what, one of the key things that they are doing in 70E to help raise the awareness that the establishing an electrically safe work condition is the most important thing. So this question and that individual leads you down this road of understanding the proper application of the code, understanding maintenance, 70B, and that helps this person understand, because this person's just asked the right question. Is a zip tie considered a lockout device? I don't know if we've got John McCamish on there, but John, would you accept a zip tie? I don't think so, but so here's the thing. That person who asked that question, it's a teaching moment. And the reason it's a teaching moment is because they had that aha moment that, wow, what am I doing, right? This personal protective equipment is my last resort. And this is the moment you help them understand, look, when you go to class and learn about this book, your concern is why you pay attention to this book. Your concern is why you dig into this book and you understand it. You understand the proper applications. 70B and maintenance, this is why it is important for you to recognize the difference between a maintained piece of equipment and a non-maintained piece of equipment. This is why it's important to understand 70B and follow the guidance that 70E tells you. When you talk about work involving electrical hazards in 130, in 110, the general requirements for safety-related work practices to follow the hierarchy of risk controls in 110.5 with regard to your electrical safety program. When it says that the hierarchy of controls, number 1 is elimination, number 2 is substitution, number 3 is engineering controls, number 4 is awareness, and number 5, administrative controls. And where's personal protective equipment? At the bottom of the list. And for that individual who asked that question, they are, you know what I look at it as? And I know guys like John McCamish and others and others, and David Engelhardt, who teaches, Felix Sandoval, I know you teach as well, Chris Folan, I know you teach, Paul. When you're teaching a student, or when you have somebody that you're communicating with, it doesn't have to be a teacher. If you're either having a debate with somebody or trying to convey what your opinion is, you'll notice when the light bulb goes off in their eyes and they go, I get it. And that's the moment that you have to sit down and say, I'm going to leverage this. Because this individual, that person who asked this question, they asked, how can I ever feel safe opening or closing a disconnect if this may be the result? How you can ever feel safe is establish an electrically safe work condition. Be aware of the condition of maintenance of everything that you were involved with and working on. And make sure that it was installed in regard to the NEC correctly. And if you have any say moving forward on any of your job sites in anything you do, if you have control of what's being installed, how it's being installed, if you are landing a wire on a termination, you've got to know the magnitude of the importance of what it is you're doing. Because our actions in our electrical industry, in our electrical installations, our actions dictate the results that may occur after the fact, the longevity of the project and the equipment. So that is a very good question. Whoever asked that question of you, I would say you did a good job, and you helped. Here's my perspective, and in your answer, and I know you're out there. So in your answer, you said you addressed how you stand and how you interact with the equipment. Okay, and I don't think that's a bad thing, but I think my suggestion to you would be is to help that individual understand that nobody has to live through shock nor arc flash when we take the certain steps and follow the hierarchy risk of controls. If they can influence the design to eliminate the hazard or reduce the likelihood and reduce the severity, if we can influence that design by using overcurrent protective devices correctly in the location, using arc reduction technologies beyond the requirements of the code, that's the only difference I think I would do in how you answered that question. I would use that as that is a very good point. And the fact that you leveraged the concept that it was a misapplied piece of equipment. And I would argue that video that we just showed of that arc flash event in that low voltage assembly, that is a properly applied piece of equipment. But energy, it's a beast. And when you let it go, what happens. So that's what I would add to that answer. 110.9, 110.16, 110.21, 110.22. He's talking about the National Electrical Code. 110.9 is your interrupting. So when you look at all of these applications, 110.9, your interrupting rating. 110.10 is short circuit current ratings. 110.16. 110.16, I want to make sure I get the titles right. Your arc flash hazard warnings. 110.21. John's absolutely right. You got to go and you've got to get back to the basics. Thanks, Willie, for joining in. You got to go back to the basics and understand that it all plays a role. And that's why guys like John McCamish, myself, and others all work very hard to educate on, yes, safety by design, Chris. We work hard. So guys like, they're the IBW, NICA guys, anybody out there that even the independent guys, and it doesn't matter who you are, what organization you're with, we all teach this. The IAEI does a great job in trying to convey the message of how the proper installations of the code. And we do that to avoid those issues. We teach these to avoid those issues. Our electrical, we build our safety plans. So, and then safety by design, Chris, you're right, going above and beyond. And I've talked about it on my channel, about that first overcurrent protective device on the secondary of any transformer. The first panel board on the secondary of any transformer, the energy is humongous, right? It's sky high. Why? Because I'm relying on the primary overcurrent device, but I don't have to live that way. All I got to do is put a disconnect. That's all I got to do. Move my energy to an area that is less likely that I'm going to have to work on energized, in a justified energized state. Help provide the ability to establish an electrically safe work condition. And get our electrical workers to do that and support them when they ask to do that. If you are, I don't know who's watching this, but if you are an industrial, if you are in a leadership role in your organization, when that electrical worker says we need to plan for an outage, then you plan for an outage. Justified energized work is hard to justify when you look at the ramifications of what can happen. Establishing an electrically safe work condition is our primary goal and objective. And if you go to NFPA 70E, and it is continuously making changes, and which is another point of what I wanted to convey to everybody. Yeah, so John McCamish is answering in the chat. John and crew are talking about those ties. You know, those ties. You can tag things with ties. You're not going to lock them out. Although we use certain things like that, you don't want to be using those nylon ties for a lockout. You can use those nylon ties for tagging, etc. I agree with you, John. But I would not use that for lockout. Now, I'm working on a document for 70E 2024 changes document, and you'll notice, and they're in mid-cycle, so they're not done yet. You will notice a bunch of changes where they're adding scope to each of these, and you'll notice that 110.1 is here's sort of what 110 is doing. They've moved some things around. They added a scope, and then look what they did with 110.2, electrically safe work condition. And they moved. They got rid of this section called energized work, and they made that an exception to the electrically safe work condition. So what you've got going on in 70E over the cycle for the 2021 and what's going on for 2024 is a shift. They're moving our sections around into the right buckets, and they're focusing on that electrically safe work condition, raising the awareness that is your first step in this process. And if you're from Canada, your process, okay? I don't care how you say it. It is important that you understand that when you are working on equipment, establishing an electrically safe work condition is important. So while I'm here on this document, I'm working on 3 documents that you can participate in. I'm taking a different approach moving forward until I'm proven wrong. I believe that creating some change documents and understanding the impact of requirements is a social effort. So what I'm doing is I am working on 3 separate documents. This is the 70E document. And you'll notice if I go to comments, I've got guys like David Engelhart. He's doing a great job. Wow. And look at this. So what I do is when you register on my website, thomasdimitrovich.com. Go to thomasdimitrovich.com. Go over here. Go to thomasdomitrovich.com. T. Dimitrovich will work too. And you go to resources, and you scroll down, and you go to registration, members only registration. That is a free registration. So you just go to register here, and subscribe to members only, and I ask for your email address, your first and last name, where you're located, a phone number, and yes, I want your birth date. Why? Because you never know. I might send you a birthday gift. I don't know. I just have the month and the day, not the year. I don't want to know how old you are, because I'll teach you about electrical safety regardless of how old you are. You can establish a membership only, and then there's contact permissions: email, direct email, phone, email marketing, and I'll tell you, I use MailChimp for my newsletter stuff and for my emailing. So if you say don't contact me via email, then you're not going to get an email from me. And I would say I'm not sure why you're signing up, but go ahead. But in any case, you will have access to some of the documents that I work on, like these. So what I do is, and if you say don't email me, you're not going to be put on this, because I email everybody. I do a share, and I put you on, and I've shared right now with 70 people. I share. I'll put you on as I think it's a commenter. I can't remember. So you can do what David's doing here. You can go in and make suggestions. And look, like he's saying, equipment's with equipment. I already accepted that one. Deals with what. And if you, and also if you have pictures, so if you have photos that you took, not that you went out on Google and found, you can put those in here, and you will get credit for that. And I don't think I have any images here, but then my goal is to publish this. So I'm going to be working on this all year. So I got 12 months. I got less than 12 months. Did you believe it's March? We're in March. It's March 4th. It's unbelievable. So anyway, so I've got these 3 documents. I will put you as not editors, commenters, I think, through Google Docs, and you can go up and add your notes. If you, and I have like an overview, if you see an impact, you can put a note that say, hey, this is going to impact this way. I have National Electrical Code and I've got 70B. The National Electrical Code is behind us, so I got to get moving on the National Electrical Code document, and we're looking for some images and pictures. If you put a picture up there, I will put in there courtesy of, and I may contact you based upon the resolution. It might be good for a web document, but it might not be good for a print edition. And my goal is once we publish it, the proceeds I'm going to hand over to the IAEI. That's just where my head's at. So that's my thought process. Okay, so that's sort of what I'm thinking there, and I'm going to have possibly three copies of this. And what I plan on doing is at the end of all of this, I'm going to take it over to Adobe InDesign, and I've already helped Bobby Joe publish a cookbook, which, if you have not yet, I'm going to do a Bobby Joe plug. You go to www.2adorabelelabs.com, 2 Adorable Labs. And Bobby Joe has a cookbook. That's Jake and Maggie. You can go to Jake's Garage. I did a piece for electrical safety in the house for her. You can view her blog where she talks about really good food, and you can subscribe. Look at this where it says subscribe. You put your email address in, and I think that's all she needs is an email, and you can get a daily dose of cuteness. And it's not a daily dose, but it's I think it's like every other day or something like that. This was a good one. Banana and Buddy Butter frozen treats. What does your dog's facial expression mean? Strawberry icing. We talked about this, and I just had a request to bring these to the Eastern section meeting. I don't think so. So anyway, that's all I got to say about that. All right. So 70, 70E, and 70B. Those are the things that I'm working on. And now I had another question. Where's it at? Okay. So this individual says, I fail to understand Table 10 of the National Electrical Code, why it lists uncoated copper wires, and then has a note saying that the values are based on type RHH wires. Now, here's my thoughts on that. Table 10, if you go to, and remember it's in a chapter 9, when you hear table 10, you got to go to chapter 9. There's chapter 8. And it's before the informative annexes. If you've hit the informative annexes, you've gone too far. Don't go too far. Table 10, conductors, aluminum, permission of under, okay, table 10? I think he meant table 9. Yeah, he meant table 9. And I forgive you for that one. So table 9 is what he's talking about. So it says in note 1 on table 9, these values are based on the following constants. UL type RHH wires with class B stranding in cradle configuration. Wire conductivities are 100% IACS copper and 61% IACS aluminum, and aluminum conduit is 45%. Capacitive resistance is ignored since the negligible at these voltages. All right, so that's note 1. And then if you look at the top of the table, it says effective Z, or alternating current resistance for uncoated copper wires. Effective Z at 0.85 power factor for uncoated copper wires. What do we mean by that when we're calling RHH? So here's where my head's at. And I don't know where I saw this. I don't think I saw this in the code. I'm going to do a quick search. But here's more. And if you're out there and if you disagree with me, please let me know. But when they say uncoated copper wires, they're not talking about the insulation around the wire. They're talking about something that we used to call, and I don't know that they do this anymore, tin coated wires. I don't know if that rings a bell. A tin coated wire. Why would they? I'm just going to search and see if that tin coated is in the National Electrical Code, and it is not. I'm going to try tin dash coated. And I don't believe that is in there either. No matches. Coated wire. So tin coated wire, tinned copper, right, versus bare copper. They would tin it. And I'm reading from a site on, I don't know what the heck, Electric Wire. So it's an organization, Electric Wire Components and Systems. So this organization is tinned copper is copper coated by a base alloy such as solder, better known as tin. Sounds simple, but there's more to it. Copper is many beneficial characteristics, making it highly desirable. However, it does have some shortcomings. This is where tinning comes into play. It's done for several reasons. Primarily, it strengthens the copper natural properties, making it better equipped to resist humidity, high temperatures, and wet environments, which is why it's found so they say it's found in marine wire. When it comes to dealing with wire and cable, blah, blah, blah. Using tin copper is an easy and effective way to prevent a copper conductor from tarnishing or becoming oxidized. You probably have seen copper when it's oxidized, it turns green. I've seen that. Hopefully you didn't give some jewelry that turned someone's neck green. The Statue of Liberty is a famous example of copper oxidation. So, and I'm not going to get into what causes all that good stuff. So, apparently they still do tinning of copper, and I would argue that when you look at tables like table 9 in chapter 9, when they say the resistance for uncoated copper wires, they are not talking about the insulation around the wire. They are talking about the tinning of that wire, if that makes sense. All right. So hopefully that answered that question. All right. Let's, and I'm going to close that. Okie dokie. Yes, they still do this for areas where corrosion is an issue. For example, the new Type P cable has conductors that are coated. All right. So John McCamish, thank you. Yes, that is correct. So okay, I got two of us. You know what? And when two say something, that means something. And we are more than 500 miles apart, so we are both experts. At one time, they used to coat wires to prevent reaction with. Oh, that's interesting. I did not know that. Prevent reaction with the rubber insulation of the day. And I'm sure that technology has changed considerably in the coatings. So that's a good thing. I like it. All right. So for my friend in Ireland who said that the links in that one video are not working, if I can find those, I will post them. If I can't find those, which I believe will probably be the case, you know who is going to be doing another session on calculating fault current using the per unit method. And I will tell you, I will do that. So I don't know. And you know what? I'm getting better at technology, so I might have a better way to do. Before I was using paper and I had an overhead camera. Remember, I called it MobiCam. I'm working on a different method to do something digitally. I gotta say it like I'm in England, where it was. Oh, okay. So in some case, you know what I'm. So in some cases. John, Mr. McCamish is saying in some cases the use of coded wire is specified, and that's a good thing to know. All right, and I'm just checking because there are some people out on all the different forums. So I've got LinkedIn going, I've got Facebook going, and I just want to check to make sure there weren't any questions. All right, so messaging. All right, so another thing. What was the other thing? All right, so channel comments. I got to go to my channel comments. I'm going to mark anyone installing in Haslock. I'm going to mark this one answered. Where's it at? Billy Smith, thanks for joining in. Oh, Billy Smith was commenting on my F-150 rust repair. I learned how to weld and use a plasma cutter, Miller 111. Miller. I can't remember my welder now. Miller 211. Miller welders. Miller welder. I have a Millermatic. I've got a Millermatic plasma cutter, and I've got a Miller. My gosh, I can't remember the number of the model. It's not a 161, not a 211. Wasn't the question about how to use the table? Well, you know, John, the question was on the table, and they didn't understand why the note at the bottom of the table said that it's based on RHH wire with a class B stranding in cradled configuration. And they said, how could they state RHH wire when the resistance is for uncoated copper wires? Now, so then that probably begs the question, where do you go for an impedance when you have copper coated wires? When you have a coated wire, where do you go for the impedance of that conductor? And if I go to each of the tables, there's a table 8 as well. What's table 8? Table 8 does have a direct current resistance at 75 degrees C, which begs another question. What do I do when I'm not in that temperature, right? Does that impact resistance? Which here's my take on it. The first thing you have to understand is, what are you using these numbers for? For example, if I'm doing a short circuit study, do I worry about adjusting the impedances of the conductors in table 9 for ambient temperature? Say it's a few degrees higher. Say it's 10 degrees higher. I don't know. Do I worry about adjusting those impedances? And my answer to that is no. And the reason is because it's insignificant. Think about all of the other impedances I'm not even including in a short circuit study. That copper bus inside of a panel board, inside of a switchboard, the impedance and the resistance of the contacts inside of a circuit breaker, the impedance of the fuse All of those they generate heat. Heat is I squared R. So they generate the heat generation in those devices. I don't include any of that. The fact that my resistance and my real and reactive components of a conductor might be a little bit more, a little bit less, in the overall schemes of things, is relatively insignificant. Now, what I may do, and I've done this in the past. For example, I did a short circuit study for a Union Carbide plant in West Virginia. I did one for a plant in Knoxville, Tennessee, Alcoa plant. And what I did there was I went to the manufacturer's data, and I downloaded their information and their impedance values, because I knew what manufacturer we had, and it was in some cases we had special conductor. But I went straight to the manufacturer of the conductor, and I used their resistance values for my short circuit calculations that I used for my coordination study and to evaluate the interrupting ratings. So I don't think that that's a bad thing. Yeah, Chris Fallen put it. And then that's what he's saying there. We would probably need to contact the manufacturer if we needed a precise number. Absolutely. And also the other thing is, like, when you're doing conduit fill calculations. Oh, John McCamish, I got a good one for you. Circular mills in table 8. Table 8 has circular mills. How are you calculating circular mills with the diameter values? Yeah, I'd love to have a chat with you offline on that one. So in any case, even in those, like when you look at circular mills of a conductor, going to the manufacturer and looking at their information, as long as that's the conductor that you're using, right, that is a good option to get data. I wouldn't even say that that's more accurate, because I'm sure there are a lot of inconsistencies in materials and whatnot whenever you're thinking about conductors or anything, right? Even if it's an impedance of a fuse, resistance of a fuse, we'll put a range down. It depends. And at one point, and I'll tell you what, and I'll tell you, at one point, when I worked I worked at a nuclear facility down in Florida, and I did voltage drop. I wrote a program. I helped write a program. I was one of the programmers on a single phase voltage drop calculation. And what we did was we took safety related, and when I say safety related, these are all circuits that are required to shut down the plant safely or keep it running, right? That needs to be kept running. So we call them safety related circuits. So we wrote a program that would do voltage drop, a study for control circuits. And what we learned, so somebody asked the question about the voltage drop down to, say, a motor through a motor starter, where we had those heater elements, right? We had a good breadth. We had Allen Bradley, we had Cutler Hammer, we had Westinghouse, and I don't think we had any Square D in there. We had whoever's it was that used the round white over heater elements. They would go over a post. I think Cutler Hammers were flat, and they had a configuration. And what would happen there is that those heater elements would heat, that would replicate heat in the motor and cause the starter to open for overloads, right? So someone asked the question on whether or not we included the resistance of those heater elements. And we had not included that resistance. So then I had to investigate the areas of the plant, what their ambient temperatures, max and min, were, and for how long. And we had some very good recording throughout the plant on temperature. So I didn't just know a max and minimum. I knew a lot more data. And then what I did was I went and I measured the resistance of these heater elements, and I put them in ovens. And I took the temperature up in the oven to where I needed to get it. And it was a significant change in the resistance. And yes, it did make a difference in my voltage drop calculations for the equipment associated with that motor, such that some relays did not have enough voltage to operate. So we had to make changes in the installation. But that was a lesson that heat may make a difference depending upon the calculation that you're doing and adjustments to the impedance values. But I've not seen any adjustments for things like the resistance in Table 9. I've just not seen it. All right, so what else? I got the PPE. I got that. I got the links are bad. I told you about signing up on thomasdimitrovich.com. I can't stress that enough. Please go out and do that. I'd love to get your eyes, and you can comment on some of the documents that I'm working on, and I'm sure I'll work on others as well. And if you do contribute and you want your name listed and you want to be recognized in the book, put your name up in the front where I've got mine, and you'll see others have done the same thing on other documents. And on the 70E, since we are mid-process, we won't be publishing that for a while, but follow us through our journey in editing 70E and 70B. All right? Okay. What else? I think that was all of the questions. Those were, I've got other questions, but I don't have enough time. I'm just going to scroll and see if there's anything really easy I can address. Willie Snyder, and he was live last night, and I didn't get the chance to watch it. Can you please explain why overload protection can be placed anywhere in the circuit? And we did answer that one. All right, so just to close up, what I want to do, need to contact them. What I want to do is remind you all that you can register for the electrical safety workshop. Remember to go to electricalsafetyworkshop.com. Get out there, register for it. You can still register. We start next week in Jacksonville, Florida. Hopefully I will see you there. Also, IAEI Western section is going to be in South Dakota. It's going to be in South Dakota, and we have registration open. I'm going to put that in there. Yes, Chris, don't complain about the codes. Do something about them and participate. And you know what I am going to do, Chris? On these documents that I'm making, and I know what I've been doing so far. I'm highlighting areas where I go, this doesn't make sense. Prime for a public input. And I think in a few cases in the National Electrical Code document, the 70 document, we did put what we would think would be the change. I am actually going to highlight public input, and I'll put it in a different box or whatever, and we will make public inputs for the next cycle together as part of that effort. So I think I'm going to have fun doing that. So anyway, I just put in the IAEI Western section registration. Go check that out. We have 19 CEU credits we'll be giving out. We're in 6 South Dakota. And we also have the beginnings for survey for the booth. Like if you want to get a booth, you can purchase some space in an ad. You can sponsor a break, and you can contribute to the code Q&A sessions. So what we do for the code Q&A sessions, we have code panel members we put up on a stage. We assemble questions from everybody out there. We give them to them. They go back and research, come up with the right answer, and then they give their answer. And I'll tell you, sometimes people in the audience don't agree. Sometimes they do. Sometimes people on the stage don't agree with each other. And I'll tell you, that's how we learn. So it can get exciting sometimes. So I will look forward to, you have the ability to submit any questions for consideration at the Western Section IAEI meeting. So I would ask that you go out, and if you scroll down to the bottom of the link that I just put in, and I'll put it out there on my LinkedIn as well, because I know the links don't show up. Let me do that. How do I do that? Oops. And I am going to do, I inspect cell tower. Oh, so Michael Savage is out there on LinkedIn. I didn't see his note over here. Michael Savage says he inspects cell tower sites with tinned copper. Coated copper. That's what we do. That's the voodoo that we do so well. Thanks, Michael, for noting that. There's the registration. I put it out there on LinkedIn. So please, this, I don't have my Keith Laughlin thinking pen has no ink in it. And I've got to go to the store and buy ink from my Keith Laughlin thinking pen. I don't feel right holding a Sharpie roller. I don't think as well without my Keith Laughlin thinking pen. So check out the IEI Western section. Also check out the electrical safety workshop.com. I will hopefully see each of you in Florida next week. And at the Western section, what else? There is another thing too. What was I going to say? There was Tuesday next week. I'm going to pre-record, but Tuesdays next week, we're going to be talking power factor correction on IAEI's YouTube site. So get over there, subscribe to it, hit that thumbs up. And remember, you got to hit the thumbs up. You've got to do me another favor too. I always do this wrong. Subscribe, right? So hit that subscribe. And if you want to hit the thumbs down button, you've got to hit it twice. It'll only work if you hit the thumbs down twice, or you can hit that thumbs up once. All right. So that's all I have to say about that. I think we're good to go. I'm good to go. I will look forward to seeing you all online. I'll look forward to seeing you down in Florida. And remember, hopefully, I don't know if you have any questions. If you got stuff you want me to hammer out, just send me an email and I'll do what I can to help answer those questions. Okay. Thank you for what you do for the electrical industry. Thank you for what you do for electrical safety. And remember to be safe and stay healthy. I'm going to sign off. Have a great weekend. God bless. Take care.